Good morning. Today I will be talking about diffuse pollution and its control on the, as you see from the Melen watershed example. I come from Istanbul Technical University from the Department of Environmental Engineering. Now, as I will be dealing with this specific watershed of Turkey, I will start with a brief introduction of Istanbul, which is one of the mega cities of the world. Now, Istanbul has a population nowadays over 14 million, according to the 2013 values. The population density is, as you might imagine, is so high, somewhat like 2,551 capita per kilometer square. And the water consumption on the average is around 2.5 million meter cube per day. Due to the global climate change issues, as you already know, Istanbul receives the annual precipitation well below the 50 years average precipitation. Between the January and October of this year, for the first 10 months of this year, it's just quite low. It is well above the 50 years average, which is 527 millimeters. So just to give you some figures, in 2007, the average precipitation was around 305.60 millimeters, and in 2013, it is the 412.40 millimeters. Now, the Melen water supply project, which we call as the Melen system, is accepted as the fundamental remedial measure for supplying water to this megacity in the long term, in the medium and the long term, because we are having water scarcity problems. And so the idea here is to supply water to Istanbul from a nearby watershed, which is what we call as interbasin water transfer. So this activity is actually conducted by the State Hydraulic Works, and it's estimated that after the year 2010, almost half of Istanbul's water supply will be provided from this nearby watershed. Here you can see the map of the country of Turkey, and here is the Black Sea, as you see in the north, and you clearly see where Istanbul is located, joining the two continents, the Asia and Europe continents. And the watershed, which is now the concern of our study, is almost 180 kilometers away from this megacity. And the Melen watershed is there within the province of Diffuse. And another thing, just to make you more familiar with the country, Ankara is the capital of the country. And the Diffuse province, where the Melen watershed is located, is just on the midway between Istanbul and Ankara. That is our project, the new project, which has been realized, the first two stages. It is known as the Greater Istanbul Water Supply Project. As you see, the pipeline is almost 200 kilometers long, with 3 pumping stations, of course, on the way. So when we come to the watershed from where we will get the water to Istanbul is a big project. And so what is necessary is, of course, to keep the watershed from where we withdraw water must be protected from any human-induced activities, from pollution, actually. So in this presentation, part of the outcomes of the project will be made familiar to you, which starts with the identification and determination of the polluting sources in the watershed, and which is the essential step towards keeping the watershed clean, so that the water will be therefore not having that much land-based pollutants. And so we will emphasize on the land-based sources that are of diffuse origin, arising from this watershed. So with a practical means, how we can estimate the diffuse pollution loads, just to give us a very rough idea about the diffuse pollution. That is the watershed. This is the map, the illustration of the watershed itself, and it's the Landsat image of the area of the watershed that belongs to August 2006. And the accuracy of these images, of this Landsat image, is around 80%, which is suitable for our work. So a series of land use classifications and verifications are done, so that the idea of using the satellite image is to find out the exact land use activities, and each land use activity will come out with different kinds of diffuse sources. So if we use such recent land use images that showing us the land use activities are good for us to make the good estimations, for healthy estimations about the diffuse sources, which will be based on the aerial values. So here you see the land use belonging to 2006 and showing us the green indicating the forests, the streams, and the meadow area, and the agricultural area in purple, you can see. And you can also differentiate between the rural and the urban areas, which are also important to make the differentiation between the urban and the rural land is important, because different kinds of diffuse pollutants at different strength will come out from these residential areas. Here there are some examples that we really used in our study. On the left hand side up here, you can see the mainstream. That is here is the Black Sea. Here is the Black Sea. That's where the Melen River ends in the Black Sea. And the water withdrawal is somewhere before it ends to the sea, somewhere here, where the water is withdrawn and transferred to Istanbul city. And these are the upstream of the rivers. It has some side branches, and then they join here. There's a lake here, and then another branch comes and makes the main channel. That is the Greater Melen Stream. And these, the ones that in the lighter blue, are the very, very side branches of the river, which are important for us just to make such what we call as the stream network, because part of the study involved the water quality modeling part. So for the water quality modeling and for the watershed modeling, we need to have such illustrations to better run the model, actually. So that is the stream network. Here, when we look to this figure, which is colorful, why we use different colors? These are the sub-watersheds. In general, this is the huge watershed, the overall watershed. But here, you can see the sub-watersheds. We need to use different colors and the different codes for each sub-watershed. They are, I cannot remember just now the number of the watersheds we use, but there are so many. When we go to the very, very details of the sub-watersheds, it gives us good information during the modeling studies. So these are all the sub-watersheds, and the huge one is the overall watershed. Here, down in this figure, we can see actually the mainstream in purple, and in red we see the side streams again, and two different codes are used. The red one, as you can see, is in the circle. These are the existing water quality monitoring stations, right? The monitoring stations that are already existing. Let us count them. One is here, the other is here, and the other two here, and the last one being here. We have 5 existing monitoring stations, which means we can collect the water samples and let them do the experimental analysis to find out water quality. But they were not enough, actually, not sufficient enough for having the good modeling study, water quality modeling study. We need more stations to get more samples because in the models that we run, actually we need more quality information on water. So we added, and we proposed different monitoring stations, and they are now added to the system. There is a reservoir here, the human made the water for water storage. So before and after the reservoir, we need to have some more monitoring stations to know the quality of the water before it enters the reservoir and what happens to the quality after leaving the reservoir. That's important, usually in the modeling studies. And we had added one here because in the previous case, in the existing ones, we don't have any idea about the water quality of the side stream, so we had to add at least one here. And another one here, just quite near to the existing final monitoring station, because there was some sort of pollution, some sort of industry settled around this area, which was very important for us. So, of course, we made an optimization study. When we mean an extra monitoring station, it means money. It means time consuming, because the monitoring station is there, of course, for the water samples. Each water sample undergoes different water quality parameter analysis, which is, of course, time consuming and money consuming. So that the additional ones, the additional monitoring stations were optimized. So when we looked on the total number is just 6 more stations are added to the already existing 5 stations. So that was quite necessary for our water quality modeling study. Here is an example of what we call as DEM, D-E-M. That is the digital elevation model, which we frequently use whenever we deal with a watershed. It's very important for us because it just gives us the information about the elevations. That is very important. The diffuse pollutants, at the place where they arise, they need to become mobile and they are transferred on the soil. How it is transferred? By the aid of precipitation. So we need precipitation. So the pollutants, the diffuse pollutants, the excess ones, travel on the soil till they reach to the lowest points, which is usually a water body. Therefore, we need to know the elevation in a 3-dimensional view. That is why just schematic diagrams. These are the aids, actually the tools that we use in the modeling studies. Okay, when we go onwards with the land use activities, here you can see the land use distribution of the watershed. That is very important to understand the types of the land use activities. Here you see the majority, almost half of the area, half of the watershed is the forestry. That is important. That is you know, the characteristics of the Black Sea surrounding countries. We have the meadows and pasture. That's what we call is just a quarter of the land, just almost 1/4 of the area, which is in majority used for livestock breeding. And agriculture is quite common in the area, which constitutes almost 17.6% of the whole watershed, and the rest is the water and the residential areas, but we prefer to classify it into categories, as I mentioned to you, the rural settlements and the urban settlements. And we have some sand area, which is of course along the seaside, along the river sides as well. So here you see the total area of the watershed, which is around 2,500 kilometers square. And the objective of this study is once more to find out to identify first, of course, the types of different diffuse polluting sources and how they are distributed among the districts of the province. In Turkey, we have provinces. We have almost 81 provinces in the country, and each province is composed of different districts. So, of course, these are the administrative boundaries. because the decision makers, the local authorities, will understand everything that is based on the administrative units. Because as you know, the countries, the provinces, and the districts are managed according to some administrative units, and each unit has the local authorities to deal with the issues, as you know. So in this study, we use the modern tools of technology like remote sensing and geographical information systems, which are abbreviated as RS and GIS. So when we come to the diffuse loads, how can we estimate them? When we already know, everybody knows the point sources, which are arising from which are arising through the piping systems, and we know their exact place. But when we come to the diffuse pollution, it is very, very difficult, as they come in a dispersed manner and in an intermittent manner. It is very difficult to calculate the amount and the quality of the diffuse pollutants. So therefore, we cannot calculate them. Instead, we can estimate them. So this is a very rough estimation method by using the unit loads based on the different land use activities that are cited in literature. So what is important when deriving the unit loads for different land use activities? One is the soil properties. The soil properties is the soil property of an area, of a region, or of a watershed is there. We cannot do anything to control the soil properties of an area. The thing is that it just depends on the geographical location and the geographical properties of the area. The humans cannot control the properties. And the second one, the second important parameter in diffuse sources is the meteorological data. And that is the precipitation and the evaporation values, which of course as humans, again, we cannot control. So these are the two important characteristics, two important properties which we cannot control as humans, but they need to be analyzed depending on the location of the watershed that we are interested in. Because the diffuse sources have the ability to be mobile by the help of the precipitation and by the different soil characteristics they vary. Then it is good to analyze them in detail, because the transportation mechanisms and the reactions that may take place throughout the way, along the pathway of that diffuse pollutant till it reaches a water body, is a huge subject. So when we refer to the transportation mechanisms, it's something else. That's what is called as the fate and the transport of pollutants on the soil. So here, instead of going into the details of the transportation mechanism, we do some sort of practical estimations depending on the unit loads. So in determining the unit loads, the aerial values for each different land use activity is important. That's why we are making use of the remote sensing, the satellite images, and the GIS. So the aerial value occupied for a specific land use activity must be known. Besides, the population figures are important. And this population, it's a good idea if you can make a differentiation between the urban and the rural population, because the pollution loads that will come out from a rural area will be different from an urbanized area. So, let's have a look for the diffuse sources of pollutants that appear in that specific watershed. These are, first, agricultural activities, because part of the area is known to be an agricultural land. And livestock breeding, of course, we have the meadows and forests, which constitute 1/4 of the area, which means that animals are breeded in the area. And the third, the forests, the urban runoff and the rural runoff, which are completely different, as you will see from the unit loads that are derived from the literature. And atmospheric deposition, if you have, of course, it will include the traffic emissions. And the dumping leachate, if you have a non-sanitary landfill, if you are in a rural area, usually in the developing countries, we come out with some unsanitary landfills where we come out with leachate, which is a strong wastewater. And then the last one, the septic tank effluents, because in the rural areas we don't have the sewer system. Therefore, the humans, the inhabitants, use the septic tanks for partially treating their wastewater. So the septic tank effluents are also considered to be part of diffuse pollution. Here you can see the different land use activities and the unit loads of the two important parameters that we take into consideration in the diffuse pollution. One is nitrogen and the other is phosphorus. The two nutrients are the important two parameters that we use in the determination of diffuse pollution. Now, we will now start with the agricultural areas first. And the data that would be required in the study of the diffuse pollution. We first try to gather data. Obtaining data is very important. So, what is the value of the fertilizers that are being sold in that region? That's very important. We start from getting data from the salesman regarding the fertilizers. And then what we do, we use different types of fertilizers, so each having different active nitrogen and phosphorus amounts. Then the second run, we look for the annual amounts that is being used in the watershed, but we look to their active ingredients of nitrogen and phosphorus. And then we just leave aside the transport mechanisms and the reactions on the way till they reach the soil, the water media, and at last we just consider how much of these nutrients are able to enter to the water environment, how much is lost through the water body. So we consider it, again, depending on the international literature, we can say that through leaching and through runoff on the surface, between 0.5 and 5% of the phosphorus and 5 to 30% of the nitrogen that's being applied as fertilizer will be appearing in the water, in the nearest receiving water body. And by the way, of course, why we are using the fertilizers? For crop production, for increasing the productivity. As you know, the crop uptake values is around 50% for nitrogen and 20% for phosphorus applied. In general, without going into the details of the crop pattern that's being used, in general, and the losses, then within this range, we assume actually a certain atypical value that's being lost, and that's of course entering to the receiving water. 15% of nitrogen and 5% of phosphorus that's being applied, we just consider it to be so in the area. The rest goes are just transferred by the transportation mechanisms. Like, for example, for ammonia, it's ammonia voltilization, nitrification, the denitrification mechanisms is being lost, and then the phosphorus is usually adsorbed in the soil and it's there for the next year. So that is showing for the specific watershed. You can see the area that is allocated for the agricultural area. You see the exact values that are derived through the remote sensing. And the nitrogen fertilizer applied per kilograms hectare per year. And then for the phosphorus similarly, and the unit loads that appear in the receiving water. That is important. So what we see here, the phosphorus containing fertilizers are used at considerably low quantities compared to nitrogen. When we look, there's a huge difference between the nitrogen that is that enters the water body and the phosphorus that enters to the water are quite different, because we don't use that much of phosphorus containing fertilizers. That's a typical situation experienced actually in almost all the regions of Turkey. This is a specific example for Turkey. In any other country, the situation might change depending on the ingredients of the soil. So, when we come to the breeding activities, livestock breeding activities, we need to get the data about the types of animals and the numbers of animals breeded annually in a certain region. And of course, we are interested in the animal manure, both in quantity and quality, because they constitute an important part of diffuse pollution. So we need to get all these, the reliable data, to say, from the local authorities. So we get we have the Provincial Directorate of the Ministry of Agriculture and Rural Affairs, which was named in the years that we studied. But nowadays, that's why I say former. Now the ministry, the name of the ministry and the duties of the ministry has a little bit changed. Now it is known in 2011 it's changed. It was June 2011. Now the ministry is named as the Ministry of Food, Agriculture and Livestock. And then the same losses that we considered for the commercial fertilizers are almost the same here. It's just an assumption. We say that the same losses to water in terms of nitrogen and phosphorus are realized because what we do with the animal manure, they are very good natural fertilizers. So it's like the commercial ones. And then in the literature, the unit loads of both nutrients for the animals, for the different classification of animals, are given according to the weight of the animals. So here, then what we have to do, we have to categorize the animals first, according to their numbers as well, and then we need to consider the average weight of these animals. And again, based on the literature, we say that 500 kilograms for the cows and cattle, 45 kilograms for goats and sheep, and 2 kilograms for the poultry. And then what we do, again, we categorize the animals, and you see for the nitrogen, for the phosphorus, the unit loads given. Well, how do we give the literatures? This kilograms per ton of animal weight per day. Okay, so then we calculate the losses from the animals, how much of the natural fertilizers may have the ability to reach to the water body. Here you can see for the different categorization of the animals, and these are cited. I just put only two of the references that I use. Andrea Dikis is from Greece, an important professor working in the field of diffuse pollution, how he categorized, and this is from United States. You see the difference, but they are so close, and these are the ones that we accepted for the region, and these are lying within the ranges of the two references. And then we come to the dump site, leachate, the septic effluents, and the atmospheric deposition. Now, the dump sites, I mean here not the sanitary ones, but the unsanitary ones, because they come out with the leachate, which is part of diffuse pollution. So in the area, in the watershed that we are interested in, there are 9 active dump sites and 1 non-active dump site. That is the solid waste landfills used in the area. Even though a landfill is non-active, it doesn't mean that no leachate will come out from it. Of course, leachate will continue to come up because of the precipitation that the area will receive, and still it will have. But diffuse pollution in terms of leachate, but of different characteristics if it's a non-active one. But it's never zero. So that is how we consider the unsanitary landfills. And the unsewered areas, usually it happens in the rural areas which are not sewered, and we have to count the number of the septic tanks that are being used. Of course, in compliance to this, to the number of the septic tanks, we need to find the number of the people living in these unsewered areas. For the rural population that are using the septic tanks, we, according to the literature again, the water that is being used is 50 liters per day per capita. It's not, of course, like the consumption in an urbanized area. And we just consider that 80% of this water consumption becomes the wastewater. That is the wastewater that enters the septic tank. And the effluent. We are now interested in the effluent quality because it will be our real diffuse type. So we say that the total Kaldal nitrogen is 60 milligrams per liter, and the phosphorus concentration is taken as 10 milligrams per liter. And here the total Kaldal nitrogen is assumed to be equal to the total nitrogen. So when we come to the atmospheric deposition, it is actually a different type of diffuse pollution. Again, it's a huge subject that really relates to air quality and air quality management. So another group of friends working in air quality modeling studies used the model which is known as the CORN-AIR program, the Copper-3 model, for calculating the traffic emissions, actually, because as I told you, the watershed is in the midway of Ankara and Istanbul. So there are 3 important highways passing through the watershed. So there's a huge traffic. Therefore, we had to run the model. For this modeling, the input data that is required is the number and the type of vehicles that pass through these 3 highways, and then they are used as the input data for the model. And at the end of the modeling study, of course, through the traffic emissions, we don't come out with phosphorus, but we come out with different derivatives of nitrogen, as you see here, the 2 polluting parameters. And after the model, we come up with what we say. Of course, by the way, we had to look for the precipitation, for the annual precipitation, because the model jointly works with the precipitation values and the number of the vehicles passing through. So for the average rainfall is the 836 millimeter per square meter of the area, and we convert it to the per hectares per year, and then the unit loads of these 2 forms of nitrogen are calculated. And at the end we make an assumption. Of course, the atmospheric deposition will not be falling to the whole watershed, but just to a certain percentage of it, which here usually most of the rough estimations, the 5% value is used. That is to say, 5% of the watershed will be the effect of atmospheric deposition. Then, these are the total values. Now, we finished with different kinds of diffuse pollution, and we calculate them separately. Now, that shows the whole. The sources of diffuse pollution here, the total nitrogen, and we use usually the annual values. So the total nitrogen, the total phosphorus values. So at the end, we come out with the total loads that would arise from the whole watershed. Now with these figures, you can go into the detail. You can then calculate district-wise calculations we can do. Or what we can say, monthly values. So the monthly values will be encountered with the monthly precipitation value. So it will not be, we will never take these values, the total value, and divide to 12, which is the total number of the months in a year. We don't do that, because then we have to take the precipitation values into consideration and then calculate it accordingly. Here is how we, in chart in the form of pie chart, this is how we can show a way of distributing the total diffuse loads. This is the nitrogen loads, the distribution of the nitrogen loads in the watershed, and that is the phosphorus load. So by looking at these pie charts, we can see the most effective ones. So in terms of nitrogen, here it is the agricultural diffuse pollutants are more important, what is followed by the livestock breeding. which is actually expected, and then the distribution of the other sources. When we come to phosphorus, the distribution is a bit different. The majority, which is almost 56%, comes from livestock breeding. It differs now. So therefore, that's one of the reasons why we work with both of the well-known nutrients. This is the way how then we can distribute. Of course, these are the names of all in Turkish, but they all indicate the different districts of the province, because each district have the local municipality and they have the local authorities. So here we make the distribution according to the districts of the watershed. This is the central town. Therefore, the majority of the nitrogen loads come from this. The colors from dark to light colors. Dark means more pollutants, and the lighter ones with the less pollutants. So here we can easily see that these three districts have comparatively less diffuse nitrogen loads, but the center is a bit high. That is for the phosphorus. Of course, in literature we can use any sort of color for illustrating the diffuse loads. It's up to you. But usually what we do, we take a single color and make it lighter or darker to show the strength of the total loads. This is again the case, and it's expected. The central town, of course, receives the majority of the diffuse pollution loads in terms of the phosphorus. And here you can see, of course, by the way, we have the point sources arising from the area, which is actually the total, the sum of the domestic wastewater discharges and the industrial wastewater discharges. Now, we're trying to classify the point sources and the diffuse sources, which are the two important sources of pollutants, and see their distribution in terms of nitrogen and phosphorus. As you see here, when we look to nitrogen, the majority comes from the diffuse sources, and when it is the phosphorus, it is not that much huge difference. The point sources is dominating with 61.5%, and the diffuse sources are less, but it's not the same for the nitrogen. Okay, when we come to the concluding remarks, what we see here, we make use of the modern technologies of GIS and remote sensing to come out with the aerial values of different land use activities. And we use these land use aerial values to identify the different types of diffuse pollutants, and then we do some rough calculations. So these rough calculations are very important prior to running models. It just gives you the rough idea about the orders of magnitude of the sources, of the quantity of the diffuse sources. And then you go into the detail and you start running with the models if you have the available data to run the models. So it is, of course, the duty of the decision maker to take the precautions, with the urgent, short, long, and the medium-term actions by using the outcomes of such studies. Now, these are finally, I'm now ending, just a few photographs from the side streams with their names, and you know these are not regulated, as you see, just a few photos for you. Thanks for your attention.